Okay, welcome girls. The goal of this lesson is to learn how to find one of the short sides of a right angle triangle if I know the other short side and the hypotenuse. So last lesson we learned how to find the long side if we knew both the short sides, but this time in this example here we're going to learn how to find B, one of the short sides. So it's one step more complicated than what we were doing in the previous lesson, finding the hypotenuse. But before we do this, we have to have a think about how we can rearrange Pythagoras' theorem. So here's a statement here, 3 plus 4 equals 7. If I think about it, I can rearrange that statement in lots of different ways. I could write it as 7 equals 3 plus 4, and it would still be true. How else could I write it? Well, I could write it as 3 equals 7 minus 4, or 7 minus 4 equals 3. That's still the same statement. Or I could write it as 7 minus 3 equals 4. Or flipping that round, 4 equals 7 minus 3. So there's lots of different ways that I can write this one statement here, 3 plus 4 equals 7. And all of these different statements are still true. I've just rearranged them. So in the same way, I can rearrange Pythagoras' theorem. Here it is here, a squared plus b squared is equal to c squared, where a and b are the short sides and c is the hypotenuse. So I could rearrange this, I could rearrange this in a few different ways. I can say c squared minus b squared equals a squared, or a squared equals c squared minus b squared. Or I could make b the subject of the equation, b squared equals c squared minus a squared. So it's just like what I did up here, rearranging the statement. I can rearrange Pythagoras' theorem. So this is going to help me with my goal today. My goal today is to find a length of one of the short sides. So let's have a look at how we might do that. Here's my triangle, and it's got a hypotenuse of 10. It's got one short side is 6, and the other short side we don't know. So first step is just to remember what Pythagoras' theorem tells me. So c squared equals a squared plus b squared. In this case, the second step is I'm going to write this Pythagoras' theorem in a rearranged way. So in this case, I'm going to write it as b squared equals c squared minus a squared, because that's going to help me find b, which is what I'm looking for here. So b squared is equal to c squared minus a squared. If you want to know how I got from here to here, all I did was subtract a squared from both sides of the equation and then flip it. But you can just take this formula and use it. You don't have to work it out every time. Okay, this should be step 3, is I'm going to substitute in the information that I know. Sorry, I copied and pasted this. Okay, I'm going to substitute in the information that I know. So in this case, I don't know what b is, But I do know what C is. C is 10. The C is always the long side. And A is going to be 6. So I've got this new piece of information. B squared is equal to 10 squared minus 6 squared. And in step 4, I use my calculator to do anything. So I work out 10 squared is 100, 6 squared is 36, and then I work out that 100 minus 36 is 64. Then step 5 is I find the length of the side that I'm interested in by taking the square root of the answer. So this is b squared equals 64. So I find b by taking the square root of 64, which is 8. Okay, so you can pause this video now and write that down if you wish. I'm going to keep going. Let's do an example. Find the value of the pronumeral. So the pronumeral here is a. So we're going to find the length of this side here. So step 1 tells me just to write out Pythagoras' theorem. So there it is there, magically. C squared equals a squared plus b squared. Step 2 tells me to rearrange it. So I want to rearrange it so that a squared is at the front. So let's go back to our first slide, which tells me the different ways I can rearrange Pythagoras' theorem. So a squared equals c squared minus b squared is going to be the one I want to use. So there that is there. A squared equals c squared minus b squared. Step 2. Step 3 tells me to substitute in the information that I know. So let's do that. I know that c is 17 and I know that b is 15. So let's write that into our equation. So it becomes a squared is equal to 17 squared minus 15 squared. So now I'm going to have to use my calculator a little bit to do the rest of this. Let's find out what 17 squared is. Okay, here's my calculator. So 17 squared is equal to 289. 289 minus 15 squared. 15 squared is equal to 225. 225. So using my calculator again, $289 minus 225 gives me 64. So let's write 64 in there. And then I'm going to use the square root button. The square root button, which is, where's the jolly thing? There it is. Square root of 64 is 8. Oops. So the length of this side here is 8 units. One more example. Find the value of x rounding to 2 decimal places. Now you might notice that they've used x instead of a or b for one of the short sides, but it doesn't really matter. We can use the same process. So let me just set up my solution. Okay, here we go. So, first of all, we write out Pythagoras' theorem. Step 1, c squared equals a squared plus b squared. But one of the things that I notice is that there's no a's and b's, there's an x. It doesn't really matter. What we can do is, instead of one of these pronumerals, a or b, we can just write x. So let's do that. So now we have c squared is equal to x squared plus b squared. So b is going to be 7.6, c of course is 10. The c is always the longest side, the hypotenuse. So next step is we need to rearrange it. So the x squared is at the beginning of our formula there. So the way we do that is the same as last time. X squared is equal to c squared minus b squared. So basically I'm taking this b squared over to the other side, subtracting it. As it goes across the equal sign, it changes signs. So x squared equals c squared minus b squared. Now our next step is to substitute in the information that we know. X squared equals 10 squared minus 7.6 squared. Then I will use my calculator. 10 squared is 100, 7.6 squared is 57.76. Subtracting those, I get x squared equals 42.24. Then I use the square root button on my calculator, and I find out that x is equal to 6.49923, and it goes on for ages and ages. We're going to round to 2 decimal places because that's what we've been asked to do. So let's go through the process for doing that. I'm interested in this second decimal place, and I have to decide whether it stays the same or whether it goes up a number. And the way I decide that is by going to the next number and seeing if it's 5 or greater. So the third number, the next number, is greater than 5. So this number here, the second one, needs to go up. Now, unfortunately, because this is a 9, it can only go up to 10. So what that does is makes this go to 50, from 49 to 50. So if I were going to write that as rounded to 2 decimal places, I'd write it as 6.50, and I put the 0 there to show that it was a longer decimal, and I've rounded it. Okay, now I want you to go to your work programs and work through the questions that have been set for you there. Don't forget, you can come back and look at these examples or this video anytime you like.